Okay, this is concept number 10, which is the Keystone polynomial problems. Okay, so these are specific problems that the Keystone uses on a nearly yearly basis. So we added them in as its own section. So it's using what you know about polynomials already and trying to find a missing value to get to your final answer. When we go through these, so we want to figure out in this first one which value of m is going to make this following statement true. This is our initial statement. This polynomial in the first set of parentheses plus our trinomial in this parentheses, we know that it's going to equal 3x to the third plus 5x squared minus 4x plus 5. So I know what all of this is going to equal. They give me the final answer. I have to figure out what this number for m has to be so that this is a true statement. Now, when you're going through these, you really only need to focus on the terms that match. Okay? You have to find the like terms that are going to matter for this specific problem. So because our m is connected to our x to the third term, you only need to look at your x to the third terms. Okay? So we're going to pull those pieces out, which is the pieces that we have underlined. Okay? That's the only term that truly matters for your final answer here. So I have an m x to the third that I'm starting with. Okay? So I carried that down here to the work. Then, and this is addition in between these two, so nothing changes about the second set. So I have an mx to the third minus a 7x to the third. When I combine those like terms, I know that it's going to give me a positive 3x to the third as a final answer. I just have to figure out this m has to be what number. So what number minus 7 is actually going to give us 3 for our final answer. So you can do it in two different ways. You can think about it logically if that works for you. If you're able to look at this and figure out, okay, something for m, I need a number, minus 7 has to equal 3. If that's okay for you to do in your head and realize that the answer has to be 10, then that's fine. Okay? There are some that it's easier to do that for rather than others. If not, you can solve this equation. Okay? We're trying to solve for m. So if this is a one-step equation, in this case, add this negative 7x to the third, add it to the other side. Move it to the other side so that this mx to the third is by itself. When I add that to the other side, I get mx to the third equals 10x to the third. Then you can see that m has to equal 10 for this to be true. So your answer for this one will be B. Now, in this second example, same basic problem as the first one, but it adds one more level of difficulty in. We are still trying to figure out what my value of m has to be to make this subtraction problem actually equal 5x squared plus 4x plus 19. So again, you first have to figure out what term or terms is going to be important from this problem. Your m is connected to your x to the first power term. So that's really the only terms that you have to pay attention to. Okay. Negative m to the x power. Then I have subtraction for this second set. Okay. You have to be really careful when it's subtraction. Because this is subtraction, remember that it changes the sign of everything in this second set. So this is no longer going to be a positive 8x. Because it's subtraction, that turns into a negative 8x when I pull it out of the problem. So I have a negative mx minus 8x has to give us 4x as the final answer. Okay, so I'm only pulling out my x to the first terms because those are the like terms with my m. Now again, I need to figure out negative what minus 8 is going to equal 4. These ones where you have some negatives involved, they're more difficult to just figure out logically in your head. So you may want to lean towards solving this equation for this one. Okay. Negative mx minus 8x, so if I add that 8x to the other side, I get a negative mx equals 12x. I need to get that m by itself. So I want to divide both sides by a negative 1. So because this is a negative m equals 12, I want to figure out what positive m equals, so I divide that negative to the other side, which gives me m equals negative 12 for my final answer then. Okay. Which makes sense. If I plug this back in, it's a negative times a negative 12, which gives us a positive 12x. 12x minus 8x is 4x. Okay? You just have to be really careful because of the negative that was already connected to m. Okay, there was already a negative there. Our answer was negative, so it switches to be a positive then when you plug it back in to check. All right, 2 more examples down below. These ones, again, kind of up the difficulty level a little bit because you have a little bit more initial work to do with these. So again, we have a polynomial expression that is shown. Okay? It tells us that all of this polynomial above is simplified to 16x to the 4th plus 6x squared plus 4x plus 10. So all of this has to turn into this answer. We just have to figure out how that happens. Now, because if you notice in this problem, these first 2 sets of parentheses, this binomial and trinomial, are actually being multiplied together. When you have the multiplication in these problems, you have to take care of that first. And so it's not the same as the other problems where we can just initially pull that m term out. I can't pull out my m term until these are multiplied together. So when I do that, I have an m x to the 3rd times a 3x to the 2nd. That's going to give me an m, 3m, x to the 5th then. Okay? When I multiply these, it's going to be 3 times whatever m is. I don't know what it is right now, but I know I'm going to multiply those 2 values together, and it's going to give me an x to the 5th power. Now, if you notice in your answer, there is no x to the 5th term in your answer. So there's no like terms for this. The only way that that could happen is that it had to have canceled out originally. Okay? Somehow this x to the 5th term has to completely cancel out because it doesn't even appear in my answer. So then we have to figure out, well, what's the like term from the second set? This is subtraction, so again, it gets distributed to this positive 24x to the 5th to make it a negative 24x to the 5th. So my like terms, so far I have a 3 times m x to the 5th minus 24x to the 5th. Okay? In order for there to be no x to the 5th in the final answer, these have to cancel. So now we have to figure out how would I make that cancel. Now the only way for it to cancel is if I have a minus 24 here, this 3m has to equal 24. 24 minus 24 would give us 0, which is what I want. So m has to be 8 in this case. 3 times 8 is your 24, which would allow these terms to completely cancel out. Same thing in this last example. It's multiplying first, so I have to multiply these together. When we do that, we get a 4m x to the 5th power. Now, in this case, I do have an x to the 5th in my final answer. Right? So then I look at my second set of parentheses to find a like term for it. In this case, I don't have a like term. Okay? This is my only x to the 5th term. But somehow in the answer, it has to turn into a 12x to the 5th. Okay? So I'm not combining with anything to turn into that 12x to the 5th. I just have to figure out what m has to be. Okay? So this 4m x to the 5th has to equal 12x to the 5th in the final answer. The only way for that to happen is if m equals 3. So a lot of this is just some mental work in your head and you being able to work your way through these using your knowledge of polynomials and how they work. Okay? So you have to be really strong in the first 2 sections of polynomials, okay, on pretest number 8 and 9. Okay, if you're really strong in those, these won't be as bad. Okay? You have to really have a good understanding of how polynomials work with the addition and subtraction and the multiplication. Okay, again, this was concept number 10, which is the Keystone polynomial questions.